welcome back to the shop. It's good to see you. Today I'm going to turn an air chisel into a concrete poker. Listen to this. Roll the titles and we'll have a play. Right, this is what I'm going to try and use. It's an air hammer I bought many years ago to chisel some bricks out of a wall to replace a window. It's a real simple bit of kit. There's just a piston in there that goes backwards and forwards under air pressure. So you put various different chisels in the nose. So let's just load one in. If I can, there we go. This spring just stops it flying out. Right, there we go, get some air. So, here's a proof of concept. There's a spring. There's a lump of steel. Let's see if this will make an effective poker. Looking promising, I have to say. Yep, I think that's going to work. This is my concept. I will take the chisel bit out of here. This bit all unscrews. There we go. Don't need the spring. I can turn this down and re-thread it, and I'm going to turn up a piece. This is a section off an old standard lamp. It's a piece of steel that's been threaded at both ends, and so what I can do is turn up an adapter piece out of a block of steel that fits between those two. So now I've got a tube, and inside the tube I can put, can that fit in there? Not quite, I have to turn that down a bit. Can put a bar that runs all the way to the bottom. At the bottom can have a weight, and at the very end of that a spring, and turn a nose to fit on the end, and that should be an air-driven vibrating poker. Okay, here we are in CAD. I think this probably will be an easier way to explain what I'm wanting to do. So let's start by turning on analysis, which gives me a cross-section view, and let's turn off a load of these bits. So to start with, zoom in. To start with, this is the, I didn't model the whole thing. This is the air hammer as it is supplied from I think it came from a UK company called Machine Mart. Anyway, here it is. I've modelled a thread on the end, but in the end I didn't use the thread, and you'll see why. So let's turn on the next piece, which is the adapter. This is a simple turned collar, if you like. I didn't put a thread on the inside, like I said. I ended up with a plain shrink fit there. And a thread on the outside, and there you go, back to the thingy. That interfaces with the tube. There we go. Let's zoom out and have a look at the tube. The tube is it's a scrap standard lamp, to be perfectly honest, and it's got a very, very odd thread. For the life of me, I can't remember what the diameter across here is. It's something weird, but it's a 1.54mm pitch, I think. I probably got that wrong. It's been a month or so since I made this, so I've forgotten, to be perfectly honest. However, it was close enough to 1.5mm pitch for me to actually make an adapter that fitted in there. So the next thing will be the hammer shaft, which basically goes through into the body of the air hammer. The end of that gets whacked by the little piston, and effectively it vibrates at this end, and it's cross drilled because if I put the, where is it, turn the hammer on, then the only way I could think to actually make sure that that hammer remains firmly attached to this shaft, I thought I'll thread it to start with, then I thought actually that could come undone. And if it came undone and unscrewed, then it would effectively stop working if the hammer moved forwards down the tube. So I thought, okay, maybe the best bet would be to just cross drill it and put a roll pin in, which is ultimately what I ended up doing. Next down the shaft is the spring, which is just there to push the hammer back into the body of the air chisel, air hammer, and finally a turned up end, and that is basically the whole thing. So if I turn the analysis off, it just looks like a tube on the outside, which is ideal. I did just for info really, I did also model up putting a little hole in the top, because I mean ultimately there's if you made a really good fit of the hammer inside this thing, then you're going to have lots of air wibbling and wobbling all inside. So I thought, I need somewhere for that to escape. So well, to go in and out basically. So I put a hole in there, but in the end I didn't need one, because I made the hammer, let's turn the analysis on again, I made the hammer, this piece here, a relatively loose sliding fit, so air can get past it. So that kind of solved the problem. But one final interesting note is the right on the end here, this this poker end, if you like, needed to be sealed with PTFE tape, because this thing runs on air, and air is effectively it sneaks past the piston in the air chisel. Let's turn around again. Sneaks past the piston in here. Then that means that my tube, because it doesn't have this little hole in it, gets pressurized, and I thought that might be a problem. So I actually sealed the threads in the end here with PTFE tape, which you'll see in the video later on, in order to try and stop air bubbles escaping, because I mean ultimately this is a concrete poker, so the last thing you want to do is start pumping it full of air. So there you have it, that's what we're going to make, and we'll get on with it. Right, so here's a quick close-up of that weird thread that came with this standard lamp tube. It's I think it's 1.54 mil. Anyway, I sorted it out and measured it accurately on the optical comparator. No video footage of that, I'm afraid, but yeah, it was a very odd thread, weird diameter, and a 1.54 pitch or something in mil. So yeah, not one that I'd come across before, or I could find any details of. So I was completely in the blank. So the first op was to cut off a chunk of steel. I thought I'd start with the very end. This is a piece that's going to be the tip of the poker, and the reason being that I thought this is an easy bit for me to actually cut the thread on and make sure that I'm going to be able to cut that thread, because it'd be soul destroying to go all the way through and make this damn thing, only to find that I couldn't replicate the threads well enough to actually make the thing, to assemble it. So here we are, just turning down the blank to accept the spring, and yeah, that's a fit, and you'll see in a minute I reduce the diameter slightly off camera and get set up to cut the first thread. Here we go. After I made a scratch pass, I used the little adapter piece that came with this standard lamp tube to check the threads. I don't have any thread gauges that are going to be exactly accurate enough, so I thought, yeah, After a little bit more fiddling and a little bit of filing, I managed to get that to fit. It's a bit of a loose fit, but to be perfectly honest, it doesn't matter. As long as it holds on nice and tightly, that's all that's needed. After turning the top slide over to, I think, around 45 degrees, just turning this to taste, really. It's the very end of the poker, and it's the bit that's going to do the business. I left a flat on the end of it because ultimately I want to be able to rattle things that are flat in section. I want to experiment with some granite epoxy castings. Castings? That's the wrong word. Mouldings. And I need a flat section on the end. That's primarily why I built this thing. It's not really for me to rattle concrete. It's for me to actually have a go at making some granite epoxy mouldings similar to castings. So the poker end is done. Now we move on to the hammer. This is the bit that's going to rattle up and down inside the tube. First port of call is to face it, as is tradition. Quinn won't forgive me if I don't. And then I turn this spigot down to fit the other end of the spring. Oh, hey, spot on. The outside diameter needs to be turned down to fit inside the tube, and this piece of steel is absolutely appalling. I'm not blaming myself, it's the steel. It looks like this was honed out with a bloody rock. It's absolutely appalling. Look at that. Dreadful. 34.8, that should be enough. Right. Oh, that's hot, to say the least. Damned hot. There we go. This is a hole in the hammer for the hammer shaft to go in. Like I said at the start of the program, I was going to thread them together, but in the end I thought it would be better to actually cross drill it. So here we go. Here's the actual shaft. A really poor fit, but who cares, doesn't matter. Well, here we go with a quick fit up to see where we are at the moment. We've got the end of the poker, the spring, the hammer, and that's the hammer shaft, and that all fits nicely back inside the tube. This is the last main part that I need to turn out of bar stock. This is the adapter piece that's going to connect the old air chisel to the new tube that I've just made. So we turn it down to diameter, put a relief groove in it and thread it. Here I'm using the face of the chuck to get the threading tool square so that the threads are at the right angles. It's a bit of a palaver to get my lathe into back gear. You have to remove this pin, undo the pin, then the main shaft is free. Then engage the back gear and Bob's your auntie. I'd already checked I'd got the right gears in the gearbox, so it's just a case of setting the Norton gearbox here, and we have a pitch of 1.5 mil. That's to engage threading, that's power feed, and that lever there I've got my hand on is the half nuts. After I've completed the first scratch pass, I use the adapter again just to make sure that the thread is exactly as it should be, the right pitch, or close as I can get it anyway. This is only a bit of the threading operation. The camera crapped out and I missed the last bit. But here we go. It's camera stopped recording, but yeah, we've got a decent fit there now. Happy with that. Right, time to take the air chisel to pieces. So the main guts of it unthreads quite easily. I did have to break it free in the vise. That piece there is one of the valves, so I put that away quite carefully, and in here is the little hammer. Surprisingly small considering this thing's actually got quite a lump when it gets going. So we put the main body in the lathe, and I turn off the threaded bit, that really coarse threaded bit that was where the spring was attached. This is the point where I tried to cut the thread relief groove and decided that this piece of steel was as hard as Hell's Kitchen floor, so I need a new plan. Right, what I'm trying to do is, this is the barrel of the air hammer or air chisel, and I want to fit this tube on there. This piece threads in here, which you've just seen me do, so actually rather than bore this out and thread it and thread that, which is tough as hell, I would be better off to turn this as an interference fit on here, heat this up and shrink it on. That'll do the job, won't it? Yep, I'm glad you agree. We'll do that. I get these big drills from model engineering shows, steam engine shows, flea markets, anywhere. I mean, 49/64. I mean, what the hell is that in real money? Who knows? But they're, you know, for a couple of quid's worth of drill, very useful for this sort of operation. They really do shift metal. So on with the boring. I changed to the largest boring bar that I've currently got, and we turn it out to slightly less, I think 0.01 or so of a mil smaller diameter than the actual diameter of the air chisel. I used my bore gauge, or one of my bore gauges, set to the right diameter to make absolutely sure that I'd got this diameter true and parallel, because I wanted to make a reasonable job of this bit, unlike most of the things I make. Yep, 25.85, that is going to be close enough. I will check that. Once we go. Let's try this. There you go, we're 0.02 millimeters under, which means I've got an interference fit in the bore of 0.12 of a millimeter, I think. Anyway, yeah, job's a good one. Knowing I'm not good at getting these things right, I do a quick test just to make sure that I've got this diameter right. Right, I use my grooving tool, parting tool in fact, to just finish this off to length. It's a bit wibbly wobbly because of the threads there, but that comes off eventually. Put a chamfer on either end of it, and then part it off, and job's a good one. Right, this is the fun bit. Who doesn't like messing around with flames and red hot bits of steel? So here we go. We'll heat it up. This is a sped up section. I think this took about 4 or 5 minutes to actually get up to temperature. It's not a particularly powerful little torch here, and I wanted to get it nice and hot to make sure it did fit. I do a trial fit once, and then we're game on, and we hammer it on. This is another small deviation from my original plan. This is one of the chisels that came with the air chisel set, and I decided that actually this would be a good piece of steel to reuse, because it's properly hardened and designed to be hit by the little hammer that's in the air chisel. So basically I just face it off and turn it down, and make it an interference fit with the hammer shaft, as you'll see, and then just heat the two up and bang them together, and again, Bob's your auntie. .12 close enough for what I want to do. There we go. Having completed all of the parts, I now need to make it all fit. So what I had to do was work out exactly how long that hammer shaft that's the steel in the background there has to be in order to wallop the hammer that I'm putting in front of the spring. Does that make any sense? I hope you get what I'm saying. It's good. That shaft there that I'm working on has to be the right length in order to wallop the hammer. If it doesn't wallop the hammer, then you'll just have something that makes a bleh noise and doesn't really work properly. So there's a little bit of trial and error in getting the length of these parts correct. But once you've done it, it seems to work a treat. Having got the length of the hammer shaft as close to correct as I could, it's time to get the drill out and cross drill and then hammer in a roll pin. So I thought the roll pin would be a better way of holding it together. Like I said, originally I was going to thread it in, which is good to some degree because it gives you a little bit more flexibility. You've got adjustment. However, I wasn't convinced that it wouldn't fall to pieces with the effect of being hammered senseless every day you use it. Right, having completed all the parts, it's time to assemble it. So off camera, as you can see, I've threaded the body of the air chisel into the tube with a little adapter between the two. That's the actual piston that effectively is the hammer. A little bit of WD-50 on with the valve, then screw the body back on, and once we've done that, we can turn it over and pop in the other parts. It's the first piece to go in is, there you go, you can hear the piston rattling in there. The first thing to do is to grease up the hammer so that it gives it a little bit more, what's the word, makes it a little bit nicer. You don't need to, but I thought, yeah, I will, I'm keen, I'll have a go. So that goes right in and inside the body of the chisel, drops in, there you go, and I sealed the end plug, the very end of this tube, with PTFE tape because as I said right at the other end of the show, the last thing you want is for air to escape out of here because the whole point is to knock the air bubbles out of your concrete, not fill it full of them. looks good. Well, I hope you enjoyed that. This turned out to be a reasonably effective tool, and you'll be seeing this again in a couple of projects we've got planned for the future. So it's the business, isn't it?